Hi brilliant minds, welcome to Math Brain. Where math becomes easy and actually makes sense. In today's video, I'll quickly show you how to convert numbers from order basis to base 10. So we're going to be converting numbers from order basis to base 10. We're working with numbers in base 2. So we're going to look at how to convert this from the base 2 to base 10. We're also going to be looking at how to convert this from the base 2 to base 10. And we'll also consider how we can easily convert this from a base 2 to a base 10. Yes. And we'll be looking at numbers in base 6 also. We're going to be converting this number from base 6 to base 10, and we'll also be converting this number from base 6 to base 10. And then lastly, we'll be looking at how to convert from base 8 to base 10, and also we'll be considering these two from base 8 to base 10. Now the thing is, if you can do base 2, you can convert base 2 to base 10, you can convert from base 6 to base 10, and you can also convert from base 8 to base 10. It means that you can convert from base 3 to base 10, from base 4 to base 10, and from base 5 to base 10. You can literally do from any base to base 10. Now let's start with the first one. 11011 base 2. We want to convert 11011 base 2 to a number in base 10. Now, first of all, to convert any number to a base 10, we use place values. We multiply each digit here by the base 2 raised to a power starting from 0. Now, this is what I mean. First of all, we assign powers to these numbers starting from 0. So we assign a power of 0 to this one, a power of 1 here, a power of 2, a power of 3, and a power of 4. So this is how it's going to look like. It's equals to 1 times 2 raised to power 4 plus this second one times base 2 raised to power 3 plus this 0 times base 2 raised to power 2 plus 1 times base 2 raised to power 1 plus 1 times 2 raised to power 0. So we've expanded this to look like this. So we have 1 times 2 raised to power 4 is 16 plus 1 times 2 raised to power 3 is 8 plus 0 times 2 raised to power 2 is 4 plus 1 times 2 raised to power 1 is 2 plus 1 times 2 raised to power 0 is 1. So we have 1 times 16 is 16, 1 times 8 is 8, that's plus 8, 0 times 4 is 0, that's plus 0, 1 times 2 is 2, that's plus 2, and 1 times 1 is 1, that's plus 1. And that gives us 16 plus 8, 24, plus 0, 24, plus 2, 26, and plus 1, 27. So we have 27 in base 10. Do not forget to add the base 10 to your answer, and that's it. Alright, so the next example we have here is 1011 in base 2. We want to convert 1011 base 2 to a number in base 10, and we'll just follow the previous example. So first of all, you know that I said we'll assign powers to each of the digits here, starting from 0 and starting from the right hand side. So from this one, we'll assign power 0 to it, we'll assign the power of 1 to this, we'll assign the power of 2 to this, and we'll assign the power of 3 to this. So we have 1 times 2 raised to the power 3 plus 0 times 2 raised to the power 2 plus 1 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. And that gives us 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. So we have 1 times 8 is 8 plus 0 times 4 is 0 plus 1 times 2 is 2 and 1 times 1 is 1. So we have plus 1. 8 plus 0 plus 2 plus 1 equals to 11 base 10. Alright, so the last one in base 2 that we are going to convert is, that's the example 3 of base 2. We have 1 0 1 1 110 in base 2. Now if you look at this, compared to the one we did earlier, you see that there's a difference here, and the difference is that this has a decimal point. So this is not a whole number. Unlike this, that is a whole number. This is not a whole number. This has a decimal point. It's pretty the same way you solve it. So let's start by assigning powers to the numbers by the left. That's 0, like we did here. That's 0. We assign power 0 here. We assign power 0 to this. Power 1, sorry. We assign power 2 to this, and we assign power 3 to this. Now to the numbers after the decimal point, we're also going to be assigning powers to them, but we're going to be starting with -1, -2, -3. Now if there are other figures after the 0, you continue. -4, -5, -6, and so on. So we have here is equals to 1 times 2 raised to the power 3. To make it easier and not to confuse yourself, you can actually put it in brackets, plus 0 times 2 raised to the power 2 plus 1 times 2 raised to the power 1 plus 1 times 2 raised to the power 0 plus 1 times 2 raised to the power -1 plus 1 times 2 raised to the power -2 plus 0 times 2 raised to the power -3. So we have equals to 2 raised to the power 3 is 8, so we have 1 times 8, we still put our bracket. 2 raised to the power 2 is 4, so we have 0 times 4 plus 0 times 4. 2 raised to the power 1 is 2, so we have 1 times 2 plus 1 times 2. 2 raised to the power 0 is 1, so we have 1. So we have plus 1 times 1. 2 raised to the power -1. Now this is it. 2 raised to the power -1 is the same thing as 1 over 2 raised to the power 1. 2 raised to the power -2 is the same thing as 1 over 2 raised to the power 2. 2 raised to the power -3 is the same thing as 1 over 2 raised to the power 3. So if you solve 2 raised to the power -1, which is the same thing as 1 over 2 raised to the power 1, it's going to give us 1 over 2, which is 0.5. So here we have plus 1 times 0.5 And here 2 raised to the power minus 2, which is 1 over 2 raised to the power 2, is going to give us 1 over 4, which is 0.25. So we have 1 times 0.25 plus 1 times 0.25. And this last one, 2 raised to the power minus 3, is 1 over 2 raised to the power 3, which is 0.125. So we have 0 times 0.125 plus 0 times 0.125. So we have 1 times 8 is 8, 0 times 4 is 0, that's plus 0. 1 times 2 is 2, that's plus 2. 1 times 1 is 1, that's plus 1. 1 times 0.5 is 0.5, that's plus 0.5. 1 times 0.25 is 0.25, that's plus 0.25. 0 times 0.125 is 0, that's plus 0. And that gives me 11.875 base 10. Now the fourth example is 254 base 6. We're going to change 254 base 6 to a number in base 10. We move from changing from a number in base 2 to base 10. Now we're going to see how it looks like changing from base 6 to base 10. The same procedure. Basically, what you do is assign powers to figures, that's 0, 1, 2, and then you say 2 times 6 raised to the power 2 plus 5 times 6 raised to the power 1 plus 4 times 6 raised to the power 0. And then we have 2 times 36. It makes it easier for you, you can put a bracket, plus 5 times 6 raised to the power 1 is 6, plus 4 times 6 raised to the power 0 is 1. 2 times 36 is 72, plus 5 times 6 is 30, plus 4 times 1 is 4. And then we have 72 plus 30, that's 102, plus 4, that's 106. In base 10, that's it. Now the fifth example is 402 base 6. I guess by now it will be easy for you to solve. But let me just do it. 0, 1, 2. 4 times 6 raised to the power 2. Plus 0 times 6 raised to the power 1. Plus 2 times 6 raised to the power 0. And that gives me 4 times 36 plus 0 times 6 plus 2 times 1. And that gives me 144 plus 0 plus 2. And that gives 146 base 10. Now example 6 is 157 base 8 to base 10. Let's see how it looks like with the base 8. Pretty much the same thing. 0, 1, 2. So we have 1 times 8 raised to the power 2 plus 5 times 8 raised to the power 1. Let's put our brackets. Plus 7 times 8 raised to the power 0. And that gives us 1 times 64 plus 5 times 8 plus 7 times 1. And that gives us 64 plus 40 plus 7. And that gives us 111 base 10. Yes, and that's it for 157 base 8. We've been able to change it or convert it to 111 base 10. Now the last example is supposed to be 234 base 8. I'm supposed to solve that, but I'm not going to do it. I want to see your answers in the comment section. So please solve this and leave your answer in the comment section. And that's it for today's smart people. If this number system solution made it easier for you to understand this topic, like the video, subscribe to this channel, and turn on notifications, because we are going deeper into number systems and you really don't want to miss it. Bye for now.